What if this isn't real? Not in a philosophical, late-night conversation kind of way. In a hard, scientific, peer-reviewed kind of way. What if the universe you're sitting in right now, the stars, the galaxies, the ground beneath you, the screen in front of you, is not the base layer of reality? What if all of it is running inside something else? This is not science fiction. This is a question that some of the most serious physicists and philosophers alive today are treating as genuinely open. And the arguments they've built in favor of it are more difficult to dismiss than most people realize. We are going to go deep today, and I want to warn you. By the end of this video, the way you look at ordinary reality might be permanently different. Not broken, not frightening, just different. Bigger. This question, are we living inside a simulated or superior universe, sits at the intersection of physics, philosophy, and computer science. And it keeps gaining traction not because people want it to be true, but because the evidence and logic that point toward it are genuinely hard to argue with. Scientists who set out to debunk the idea often end up saying something like, "We can't rule it out. I've been studying cosmology, theoretical physics, and the philosophy of science for years. I've tracked every major paper on this topic, from Nick Bostrom's original simulation argument to the latest work coming out of quantum mechanics research. And my honest assessment is this. This is one of the most important questions anyone has ever asked. And we are closer to being able to think about it scientifically than at any point in history." So here's what we're covering. First, the actual scientific case for why our universe might exist inside something larger. Second, the specific clues hiding inside physics itself that have made serious researchers take this seriously. And third, the deepest implication of all, what it would mean for you, for consciousness, for meaning, if this turned out to be true. Let's start with the basics, and I mean the real basics. What is a universe? At its most fundamental level, a universe is a set of physical laws operating on a set of initial conditions, evolving over time. That's it. The laws of physics in our universe, gravity, electromagnetism, the strong and weak nuclear forces, are the rules of the system. The Big Bang was the initialization. Everything since then is the output. Now, here's the question that changes everything. Is there any reason those rules have to be physical? Is there any reason the laws of physics have to be written into the fabric of something material? Or could they just as easily be written into the logic of a computation? Because information and physics have a relationship that scientists are still trying to fully understand. At the quantum level, the deepest level of reality we can probe, the universe behaves in ways that look remarkably like a system processing information. Particles don't have definite properties until they're measured, until something interacts with them. The act of observation seems to matter in a way that it simply shouldn't if reality is purely, straightforwardly physical. There's a phrase some physicists use, "it from bit." The idea, associated with physicist John Wheeler, is that physical reality emerges from information. That at the bottom of everything, what exists is not matter or energy, but data, answers to yes or no questions, bits. If that's true, if reality is fundamentally informational, then the line between a physical universe and a computed one becomes very difficult to draw. Now, let me introduce the argument that has made this a serious, scientific and philosophical conversation rather than just a thought experiment. In 2003, philosopher Nick Bostrom published a paper laying out what he called the simulation argument. It's a logical argument, and its power comes from the fact that it's very hard to escape. Here's the core of it. One of three things must be true. Either almost all civilizations at our level of technological development go extinct before they develop the computing power to run detailed simulations of conscious minds. Or almost all civilizations that do reach that level of technology choose not to run such simulations for some reason. Or we are almost certainly living in a simulation right now. Read that slowly. If advanced civilizations survive, and if they choose to run simulations, and given how many of them there would be across the universe and across time, they would run enormous numbers of them. Then the simulated minds would vastly outnumber the non-simulated ones. And if that's true, the statistical odds that you are one of the rare, non-simulated minds approaches 0. You are almost certainly in a simulation, unless civilizations either die before they get there, or consistently choose not to run them. I want to stop here and ask you something. Right now, honestly, does this idea feel impossible to you? Or does it feel uncomfortably plausible? Drop your answer in the comments, because the split in how people respond to this argument is itself fascinating. Some people hear it and immediately feel it's obviously wrong. Others hear it and feel like something clicked into place. Either reaction is worth examining. Now, here's where physics enters the conversation in a way that gives the simulation idea more than just philosophical support. Our universe has a resolution limit. There is a smallest possible length, called the Planck length, below which the concept of distance stops making sense. There is a maximum amount of information that can be stored in any given region of space, described by something called the Bekenstein bound. The universe, at its finest level of detail, appears to be pixelated, quantized, discrete rather than continuous. That's exactly what you'd expect if the universe were a computation running on finite resources. A simulation has to make choices about resolution. It can't render infinite detail everywhere. It renders what's being observed at the resolution needed, and leaves everything else in lower fidelity until something looks at it. And here's something that sounds almost designed to make physicists uncomfortable. Quantum mechanics, the most successful and precisely tested theory in the history of science, tells us that particles genuinely do not have definite properties until they are measured. Until something interacts with them, they exist in superposition, spread across multiple possible states simultaneously. The act of measurement collapses that superposition into a single definite outcome. Render on demand. Only process what's being observed. That is a profoundly computational way for a universe to behave. Is this proof? No, absolutely not. There are other interpretations of quantum mechanics that don't require this reading. But the point is that the behavior of reality at its deepest level is not inconsistent with the simulation hypothesis. In some ways, it fits uncomfortably well. Here's the other piece that doesn't get enough attention. The constants of physics in our universe are fine-tuned to a degree that is genuinely difficult to explain by chance. The strength of gravity, the mass of the electron, the cosmological constant, the energy density of empty space. Change any of these by even a tiny fraction, and the universe as we know it doesn't exist. Stars don't form, atoms don't hold together, life becomes impossible. The probability of all these constants landing in the narrow range that permits complexity in life, by pure random chance, is vanishingly small. There are naturalistic explanations for this. The multiverse, for instance, which proposes that all possible universes exist, and we simply find ourselves in one compatible with our existence. But there's another explanation that is equally consistent with the evidence. Someone or something chose these constants, set them deliberately, designed a universe where interesting things could happen. That's not a religious argument. It's a design argument. And in the context of a simulated universe, it makes complete sense. A civilization running a universe simulation might very well tune the parameters to produce complexity, to produce stars, planets, chemistry, biology. To see what emerges, we might be the emergence, here's the deepest part of all this. The part that I think matters most, regardless of whether this simulation hypothesis turns out to be true. If we are in a simulated universe, a universe created by something above us, something with intentions and purposes we can't fully see, then consciousness, experience, meaning, love, suffering, discovery, none of it is less real. A simulated mind that feels, thinks, and loves is still feeling, thinking, and loving. The substrate doesn't change the experience. What it does change is the question of what's possible. If our universe exists inside something larger, then the boundary of what can happen is not the boundary of our universe. It's the boundary of whatever contains us. And that boundary might have no limit we can currently imagine. So let's land this. The simulation argument, built on pure logic by serious thinkers, says that unless civilizations regularly go extinct or consistently choose not to simulate minds, we are almost certainly simulated. Physics itself, at the quantum level, behaves in ways that are at minimum consistent with a computed reality. The fine-tuning of physical constants suggests either extraordinary coincidence, an infinite multiverse, or intentional design. And our universe has a resolution limit, a smallest scale, exactly as you'd expect from a system running on finite computational resources. None of this is proof, but the honest scientific answer is, we cannot rule it out. And the fact that we can't rule it out is itself one of the most extraordinary things about the moment in history we're living in. If this video shifted something in how you see reality, even slightly, hit that like button. It helps more people find content that takes these questions seriously. Subscribe, because we go somewhere in the universe that most people have never thought to look. Real science, real implications. Thanks for watching. Whether this is base reality or something inside something else, you are here. You are aware, and that, whatever it means, is extraordinary.